Okay, hello everyone. And Morpheus said, throughout human history, we have been dependent on machines to survive. Fate, it seems, is not without a sense of an irony. So, do you think we will have the same future with advancement in AI or not? Nobody knows, but we hope not. Okay, my name is Javokhir Shoyusupov, and I work as a DevOps engineer and a little bit Gen AI enthusiast. And today we will talk about building blocks of Gen AI, and we will cover components like what is Gen AI and its difference from ordinary AI, how it works under the hood, and what are some problems of AI, and how we can customize existing AI models for our own purposes. So many of you may think that AI came out just recently in like few years, but generally it was a natural step in development of human history. If we look back, you can see that in 1981 PC had only 64 kilobytes of data, and then we quickly moved to megabytes, then gigabytes, terabytes, and even petabytes. And companies like AWS, Microsoft, and other big tech companies are already working with exabytes of data. And what will happen when we reach a zettabyte scale? Well, you don't have to imagine, because due to Statista website, around 120 zettabytes of data will be produced in 2024, which is pretty big. And somehow we should efficiently handle this data, because our human brains and existing PC solutions are not able to efficiently handle and use this data. So many smart engineers have found the answer, which was machine learning and AI. Okay, so many people think that AI and machine learning is the same thing, but in reality, it's kind of not, because AI is an ultimate purpose of what we are all doing. It's an analog of human brain that can do similar tasks, and it is the what. And ML is machine learning, is what powers artificial intelligence. It is the technologies that it uses under the hood. And what is a Gen AI? Gen AI is a type of AI that generates or like produces some new material as it works. For example, ChatGPT, it might be text, or DALL-E, it might be image, audio, or video. All of these artificial intelligence are called Gen AI because they produce something as a result. And in comparison to like uh, predicting stock prices on the market, that's not a Gen AI. And again, many of you might think that AI came out in like lately 10 years or so, but in reality, first AI was created in 1951 in England. It was a basic AI that was playing checkers and chess. And back in the time, it looked like this. It was a bunch of pretty complex if-else statements or pretty complex switch statements. And then it, of course, evolved, and now it's way more complex. Now we have so-called two types of models. One of them are traditional ML models, which are trained for a specific purpose. For example, image recognition, or a chatbot, like predicting stock prices, etc. And they do not hold the general knowledge, and they could not serve a general purpose. So how it works under the hood? Well, to train an ML model, we first should label a data like this. For example, if we want to build a ML model that will distinguish cat and the dog, we gather lots of we get lots of data, then we label it, and then we use this data to train our models. And this is called supervised learning, which means that our AI gets the data, and also it gets the like hint, what is it? And of course, we have the opposite, which is called unsupervised data. And unsupervised data, we do not label it, and it's a little bit easier, because again, you don't spend your time, you just give it information, and then AI identifies some interesting patterns. For example, you can, if you have your shop, you can collect all your cashier checks and give it to AI, and then it will identify some interesting patterns. For example, that people are buying bread and butter together, or maybe not, or some other interesting patterns. So you don't give it any prompts, it gives you a prompt. based on the data that you have provided. And the traditional models are not the only one. Recently was created so-called foundation models. So foundation models, in comparison to traditional models, hold the general knowledge, like ChatGPT is an example of foundational model. They are trained on a vast majority of data, probably like the whole internet or so, and they can serve several purposes, like making your homework or creating a speech for you or whatever you want. And why this was not possible before, or what was the reason of creating these foundation models? Well, in 2017, the article called "Attention is All You Need" was published by some Google developers and university professors. By the way, you can find it in the internet. It's not so big, about like 20 pages or so. And this exact paper described so-called transformer architecture. Or you can take a picture. Yeah, so it introduced the transformer architecture. Well, it's not related to robots, but yeah, here on the right side, you can see how it looks like. You can see that you can, okay, it's pretty complex. I will describe like very high level overall view of this. We will not dive very deep, but how it works under the hood. First of all, when the input is taken, it's divided into so-called tokens. And tokens might be it might be a character or word or semi-word or small part of an image, small part of an audio or whatever. In this example, it's like a semi-word. And then when we divide our input into tokens, then what happens? These input are embedded. So what is embedding? Embedding means transforming a token into this array of numbers. In this example, you can see like bottle and Coke. And what you can mention is that they are pretty similar. That's because vectors hold a semantic meaning of word. For example, they are both liquids, they are both in the bottle, and we drink them. That's why they will be pretty close to each other. And here, I can show you a quick example of this. If we visualize these graphs, you can see that they are located pretty close to each other because they hold a pretty similar semantic meaning. And also, I will show you pretty quick Python example. If we embed a word, for example, we try to embed a king. I've used some Google News embedding database. You can see that it's pretty big. It's very, very big, not like 3 dimensions. And ChatGPT has about 12,000 dimensional vectors for each token, which is huge. And each of these numbers hold a semantic meaning. And also, we can do some interesting stuff with it. If we take a vector of Tokyo and then we do Tokyo minus Japan plus Germany, apparently we will have answers like Frankfurt or Berlin or Düsseldorf. Then what happens next? You have divided your input into tokens, and then as you can see here, there are multi-head attention mechanism, and which uses a self-attention. This mechanism allows us to find the dependencies of the words in your sentence. Here you can see that smart is related to dog, and what this mechanism does, it identifies such dependencies. And for example, if you will say it like draw me a white cat, it will understand that white is related to cat, and it will draw you exactly white cat. And here you can see the first step is embedding, and then it will go to multi-head attention. What is multi-head? It is just self-attention mechanism runs a lot of time in parallel to get a better performance. And the next feature of transformer architecture is positional encoding. So words in our like human language have positions, and the positions are not random. Each word, each located in each position has a special meaning, and this meaning is passed to our architecture also, like here you can see, and here also. And then these positions are used also to generate a better output for you. So these are the main tricks of this transformer architecture. We will not go further, and we will maybe get some more practice. And what it led us to do, this foundation model architecture, it allowed engineers to build dozens of foundation models, like even more than JavaScript frameworks back then. And now we can highlight some of them are like Claude by Anthropic company, which is pretty promising, and it's free, so you can try it. It's like ChatGPT, but in my opinion, a little bit more accurate. Also, we have a Mistral, and of course, AWS has also its own foundation model called Amazon Titan, and though AWS encourages you to try it, they believe that no foundation model will rule them all. So each of them has its own benefits, pros and cons, so you should try them all and found which suits your purposes and where you can try them all. So you can try them all on Amazon Bedrock service, which is an AWS service where there are available like majority of most popular models, which is itself pretty cool, but you can do even more with it than just playing around. We will talk about it a little bit later, but now we will talk about problems of foundation models a little bit. Since they hold a general knowledge, they tend to make some mistakes, and it's called a hallucination. So similar to people, these models can also hallucinate, and we need some mechanisms to make our answers better by implementing customization techniques, or not just to overcome hallucination, maybe to adapt this model for our own businesses. We will talk mainly about three techniques: fine-tuning, continued pre-training, and retrieval augmented generation. And you can do this on this Bedrock service. So fine-tuning is an example of supervised learning, as I've talked before. So you give it a prompt and you give it the answer. So you label your data, and then you pass it to your foundational model and get the endpoint. Here, how it works, again, this code is in Python, but it's pretty simple. So you choose your base model, which is a comment in this example, and obviously you choose a customization type fine-tuning. Then what you do, you pass your input data and put a location of output data. This might be S3 bucket or like another storage. And what you get an endpoint. And then in your code, you use this endpoint with a foundation model that has information that you've passed it. Maybe about your company internal sales or whatever. Continued pre-training is an example of unsupervised learning. Well, again, so when you pass your data and you don't label it and it learns by itself, the technique is pretty similar. The only difference is that you choose a customization type continued pre-training, and the other stuff is pretty similar. You again get an endpoint, which you can use in your code. But that is pretty simple itself. But if you want to make it even more simple without single line of code, you have an option via Amazon Bedrock UI. So you have two options: create a fine-tuning job and continue pre-training job. Few clicks of mouse and you have your customized foundation model. Then we will move to some more interesting stuff called RAG, and that's how it works overall. So for example, you want to make a chatbot that will communicate with your customers and provide some information about sales. But models in general, for example, ChatGPT or Claude or other models, they do not know about your website and your sales. So you should somehow teach it. And that's how it will work overall. So user will ask like, are there any sales? Then our RAG will go to database, get the answer, provide it to foundation model, and foundation model will provide the answer. So if the request was like, are there any sales? It got the data about, yes, example shop offerings here, 20% off. It combines the information that it got from database and combines user prompt and passes it to model. And then model says, yes, you have, because the input said so. How it works under the hood? So first you take your knowledge base, your sales information, and you vectorize it. Again, as I explained before, what is vectorization? And then you put it into your vector database. Why you put it into vector database and not in like MySQL database or some other database? Because it has a feature like similarity search. and some other features. As I've also showed visually, similarity search of vectors, which is pretty handy because when user asks a prompt about sales, it should find similar answers or similar information in its database. Then the user gives a prompt after you put all your data into your database, and then it also gets vectorized, and you make a search in your database. Not you, but the system makes a search, and then the retrieved vectors are turned again into text and combined, passed to foundation models, and you get the answer. And how you can do it on AWS website? So there is a Amazon Bedrock knowledge base. That's again managed service. And what you can do is you just, well, you can use your own vectorized database and connect it here, etc. But you can just click create knowledge database and then upload all your data. It will host a database. It will host a database for you. It will do all the job for you, and you will just get an endpoint and use it. The only thing, you just collect your data that you want to pass, click the button, and that's it. Okay, that was the end of my presentation. Hope you've learned something new and how it works under the hood and how you can implement it. The crucial point of this presentation is how you can implement all these cool features without knowing any mathematics and without having a deep knowledge in machine learning and training your own models. Okay, and that's it. Yeah. Yes, now it's time to questions. Any questions?